Hey there and welcome. Today we're going to do a little bit of code breaking. We're going to crack the secret code that's hidden inside every single straight line you've ever seen. And trust me, it is way simpler than you think. Let's get right into it.
Really think about it for a second. A line looks so simple, right? But it's actually this perfect, totally predictable pattern. And you know what? Every pattern has a code. So today, we're going to figure out how a simple equation, that little string of numbers and letters, is the secret key to unlocking the whole thing.
So, to crack this code, we need a special tool. Let's imagine our equation is like a simple machine. You pop a number in one side, we'll call that our input. The machine does one simple thing to it, and boom, a new number comes out the other side. That's our output. It's really that straightforward.
And here is the big central idea that makes all of this work. To see the pattern really clearly, we're going to use a table to keep all our inputs and outputs organized. The secret we are hunting for is this. For a line to be perfectly straight, the change in the output has to be consistent every single time the input changes. That consistency, well, that's everything.
So how do we actually do it? It's just a simple three-step loop. First, you pick an input number. Let's call it x. Second, you run it through the rule from our equation. And third, you just write down the output number you get. We'll call that y. That is the entire decoding process. So let's actually put it to the test.
All right, let's build our very first line. Here's the secret code. Y equals 2x plus 1. So what's the rule? Super simple. Take whatever input x you choose, multiplied by 2, and then add 1. Let's see what kind of pattern this machine cranks out.
Okay, check out this table. We put in a -2, and our machine spits out a -3. We put in a -1, we get a -1. Put in 0, we get 1. Hang on, are you seeing the pattern here? Every single time our input x goes up by 1, the output y jumps up by exactly 2. It's this perfect, steady climb.
And here's where it gets really cool. Each of those pairs, the input and the output, isn't just a pair of numbers. They're coordinates. They're the exact location markers, like little X marks the spot pins that tell us precisely where to draw our line on a map or a graph. Feeling good? Awesome. Let's try one more just to make sure we've got this down. Our new rule is y equals 3x minus 2. It's the same process, just a different code. So what do you think this pattern is going to look like?
Let's look at the data. Input is -2, output is -8. Input is -1, output is -5. So, what's the jump this time? As our input x goes up by 1, look at that. Our output y is jumping up by 3 every single time. This one's a steeper, faster climb than the last one.
And this, right here, this is the big aha moment. That consistent change, that jump of 3 we just found, that has a name. It's called the slope. It's the secret number that tells us exactly how steep our line is. In our first example, the slope was 2. Here, it's 3. You can see it right there in the equation. Okay, code breakers, time for a plot twist. We've seen lines that climb up. But what happens if our rule has a negative sign in it? Our next mission is to decode y equals -x plus 4. Does this just flip the whole thing on its head? Let's find out. Okay, let's hunt for the pattern. As our input, x, gets bigger, it's going from -3 up to -2, then -1. Take a look at what the output y is doing. It's going from 7 down to 6, down to 5. It's getting smaller. We have a perfectly consistent decrease. So, that's our answer. That little negative sign in our code completely flipped the direction. Instead of climbing up, our line is now sliding down at a steady, totally predictable rate. Pretty cool, right?
So we've basically decoded the two main types of lines. You've got your climbing lines with a positive slope. As x gets bigger, y gets bigger too. And you have your sliding lines with a negative slope. As x gets bigger, y gets smaller. One goes up, one goes down. It really is that simple.
So let's wrap our heads around what we just did. We started with what looked like just a random string of numbers and letters, this abstract little rule. And by using a simple table, we turned that rule into a clear visual picture.
And this is the most important thing to take away from all this. That table we were building, it's not just busy work. It is the bridge. It's the thing that translates the language of algebra, the code, into the language of geometry, the picture. It's what makes the invisible visible.
Now, to wrap things up, the source material that inspired this explainer connects this whole mathematical idea to a bigger life lesson, and it concludes with this specific quote from the book of Joshua.
So the source makes this really interesting metaphorical connection. The idea is that just like following the clear rule of an equation gives you a predictable straight line, following a clear path or a set of principles in your own life can give you a similar kind of direction and strength.
So I'm going to leave you with this final thought. Now that you know how to crack the code, what patterns in your own world follow a straight line? Maybe it's how much money you save every week, or the distance you try to run each day. The world is absolutely full of these straight lines, and now you know exactly how to read their secret code.